Okay, good afternoon. Is the slide visible? Anybody else, please respond. Yes?
No, sir. Slide is not visible, sir.
No, sir.
Anybody else, please respond whether the slide is visible.
No, sir.
No, sir.
No, sir.
Slide is
No,
not
sir.
visible.
No, sir.
Okay, let's see. Now is it visible? Hello?
No, sir.
No, still no. Okay, so some problem. Let's see. Okay, now is it visible? Hello? Hello?
Yes, sir.
Yes, sir.
Okay. Let's see, is it now visible? I have just hidden it. Now, hello? Anyone? Hello?
Sir, your voice is crashing.
Voice is crashing. Okay, now is it visible and audible? Hello? Yes?
Yes, sir.
Okay. So now let's continue. We'll see the last portion of quality management. Okay, so we are continuing the software quality management. Last class we have discussed about one standard for the software quality, that is ISO. We had seen the advantages and the drawbacks of ISO. Several drawbacks I have told, like if there is no standards, you can say, or some of the registrars may be lenient, some of the registrars may be very strict, and some other what drawbacks we have seen. Now let's see how some of the drawbacks, how they can be removed. Now today we'll see another such quality model called as ACI CMM model, which stands for ACI stands for Software Engineering Institute and CMM stands for Capability Maturity Model. So this ACI CMM model, it was developed by Software Engineering Institute of the Carnegie Mellon University, USA. Why this was developed? So this model was developed to assist the US Department of Defense in software acquisition, how they can how they can acquire software, how they can go for acquisition of software, maybe through tendering process or so. So to develop this acquisition of software, this US Department of Defense has developed this model. Okay, so this model was developed by Software Engineering Institutes of the Carnegie Mellon University, USA. Why? This was developed to assist the US Department of Defense in software acquisition. What are the requirements? As a factor in contract. To consider the rationale.
Hello, sir.
Yes, yes.
Lights are not changing.
Yes.
Lights are not.
Then I have not changed.
Okay.
I have not changed. Okay. So the rationale to the lighting performance as a factor in contracting or in giving contracts or in awarding contracts. Okay. The rationale was to include the likely contractor performance and contract awards. Now let's see the important characteristics of ACI CMM model. Major Department of Defense contractors, they began CMM-based process in improvement initiatives as they vied for DoD contracts. So while these contractors, they were applying for the contracts or they are trying to participate in the contract awarding process, they tried to begin this CMM-based process improvement initiatives. This ACI CMM model, it helped the different organizations. How these models, these models helped improve the quality of software they develop. Okay, so this is ACI CMM model. It helped the organizations to improve the quality of the software that they have developed. This model also realized the adoption of ACI CMM model. It had significant business benefits. So the organizations who had realized adoption of ACI-CMM, the organizations who had adopted this ACI-CMM model, they felt that they had significant business benefits after adopting this ACI-CMM model. So then other organizations, they have also started adopting CMM. Okay. Then other organizations, they adopted CMM also. In simple words, we can say that this CMM is a model for upgrading the software process maturity of a contractor into different levels. Okay, this CMM, it can be considered as a model. CMM is a model for what? For upgrading the software process maturity of a contractor into different levels. We'll shortly see what are the different levels. There are 5 levels. I will see after a few minutes. So this ACI capability maturity model, ACI CMM model, it can be used to the most likely outcome to be expected from the next project that the organization undertakes. In future, what project the organization will take from that project, what most likely outcome it can be obtained, it can be predicted. So this can be done by using this ACI CMM model. This ACI CMM model, it can be used in 2 ways. First, for capability evaluation. Second, for software process assessment. Okay, so the CMM model, it can be used in 2 ways. Number 1, for evaluation of capability, and number 2 for assessment of the software process. Okay. We'll first see the capability evaluation, then we'll see the assessment of the software processes. We'll first discuss about the capability evaluation. This capability evaluation means the capability evaluation, it provides a way to assess the software process capability of an organization. Okay. So this capability evaluation provides a way for what? An organization software process. So this capability maturity model, it provides a way to assess the software process capability of an organization. This also helps in selecting a contractor. If you are going for a awarding, if you are going for awarding some contract, then this model, it help you in selecting which will be the best contractor. It helps in selecting the contractor. It also indicates the likely contractor performance. What is the performance of the contractor, or what is the likely contractor performance, that can be indicated by this CMM model. Then next way to use this software process assessment, CMM can be used by an organization to assess its current process, what process it is following, because last class I have told, if the process you are following, it is good, then the final output, the product is bound to be good. So this CMM model, which is used by an organization to assess its current process. Okay, so this capability maturity model can be an organization's current process to assess its existing process. This model, okay, this model also suggests the ways to improve the process capability. This model, it can give you also some suggestions. It suggests the ways to improve the process capability, how your process capability can be improved. It can give some suggestions. Please remember, this type of assessment is purely for internal use, not for any external use. So this type of assessment is for purely internal use by the organization, or by the you can say by the development organization. Now let's see the details of HCI capability maturity model.
Excuse me, sir.
Yes. Yes.
Sir, I think slides are not changing, sir.
Now changing. Hello. Now is it change the figure? Are you able to see?
Not yet, sir.
A figure you are not able to see. And what you are observing in the screen? Which slide?
Sir, only the first page.
First page. So any other? Please, any others? Whether you are able to see the momentum slides or not?
Sir. No, sir, not able to see the slides.
We are only seeing the
Not visible, sir.
Sharing mode. So just say, is it now visible? What figure is visible?
Yes, sir.
Hello?
Yes, sir.
Yes,
Now
sir.
it's visible.
A figure is visible? Okay.
Yes, sir.
Okay, so whatever we have discussed, only the fundamental things. Actually, from here, actually, it will start. This main levels, the important characteristics of CMM will start now. So now let's see in detail the SCI capability maturity model. The SCI CMM, okay, before this, I think I have told that this type of assessment is for purely internal use, not for external use. The SCI CMM, it classifies software development industries into 5 maturity levels, very much important. Okay, so the SCI CMM model, it classifies the different software development industries into 5 maturity levels. The stages are ordered in a way so that improvements at one stage provide foundation. You are at a lower level. If you can make some improvements, then you can go to the next level. Then at that level, if you will further do some improvements in your process, you can go to next higher level, like that. So that's what I'm saying. The software development industries are organized into 5 maturity levels. They are classified into 5 maturity levels. There will be 5 stages. These stages are ordered in a way so that the improvements made at one stage, it provides the foundations, the basics for moving to the next stage. This SCI-CMM model, it was based on the pioneering work of a great software engineer called as Philip Crosby. Okay. Now let's see what are the 5 maturity levels. As I have already told you that SCI-CMM model, it classifies the different software development organizations into 5 levels. These are the 5 levels. Level 1 is the initial level. Level 2 is the repeatable level. Level 3 is called as defined level. Level 4 is called as managed level. And level 5 is called as optimizing level. Okay. So if you are assessed, if your organization, if your company is assessed at level 1, that means you are at the initial level. And it is assumed that only your processes are disciplined, or you are at the initial level. If you will follow some disciplined processes, then you can go to repeatable level 2. Level 2 is repeatable. If your organization is assessed at level 2, that means you are at repeatable stage. In order to go to level 3 or the defined stage, what you have to do? You have to follow some standard, some consistent processes. Now, suppose you are in or your organization is evaluated as level 3 or defined level. How you can move to the next higher level? If you can predict the process. If your processes are predictable, then you can go to the next level, that is the managed. And if you are at the managed level, level 4, how you can go to the top level? The topmost level is optimizing level. You have to continuously improve the processes. If you can continuously measure and improve the processes, then there is a chance you can move from level 4 to level 5. So these are the basic levels of SCI-CMM model, and in which level, what activity you should perform so that you can go to the next level. That those things are written in the right hand side. Now let us discuss in detail. So now suppose your organization is evaluating initial level. What does it mean? You can draw the following inferences. First, the organization operates without any formalized process or project plans. Your organization is not it is not following any formalized process or project plan. Nothing, purely ad hoc. Your organization operates without any formalized process or project plans. An organization at this level is characterized by ad hoc and often chaotic activities. The activities you are following, the processes you are following, they are purely ad hoc, they are chaotic. You are not following any formalized process or systematic process or formalized project plans. So, you are rated at initial level, level 1, nothing. All the processes are ad hoc, they are chaotic, you are not following any formalized process or project plans. So that's why you are at which level? You are evaluated at initial level. Now if you want to go to repeatable, next level, level 2 or repeatable, what you have to do? As you have already known, your processes are all ad hoc and often they are chaotic. They are not formalized. So you have to first make them formalized. The processes have to be formalized. There you should follow systematic processes. So that's why what you have to do? Discipline your processes. You have to define your processes. The processes should be more disciplined, they should be systemized, they should be formalized. Then only you can go to the next step or next level, that is repeatable. So now So if you are in that level 1, we are continuing. What other inference you can draw? The software production processes that you are following, they are not defined. Different engineers, they are following their own processes. They are not sticking to some systematic process. Different engineers, they follow their own processes. It's chaotic, totally chaotic, because no systematic process, no formalized process is there. So the development efforts become chaotic, and the success of projects depend on individual efforts and heroics. So whether a project will get success or not, it depends upon the individual engineers, their individual efforts, because nothing is formalized, nothing is documented. Every people, they are following their own processes. So that's why the success of projects depend on individual efforts and heroics. Okay. Now let's say if your organization is at level 2, that is repeatable level. So what does it mean? What inference you can draw? So if your organization is evaluated as repeatable, then you can draw the following inferences. You are following basic project management practices. Now the approaches or the methods, the processes you are following, they are not ad hoc. They are not, you can say that they are a little bit formalized. You are following basic project management practices, such as you are tracking the cost, tracking the schedule and functionalities, tracking the functionalities, they are followed. The processes are more or less, they are systematic, they are formalized. Now you are using also size and cost estimation techniques such as function point analysis, COCOMO, etc. But the production process is still ad hoc. So here we have already seen that the process is ad hoc. The ad hoc and often also the organization which is evaluated at an organization at this level is characterized by the following fact: it is ad hoc and often chaotic activities are used. So, but here a little bit improved. You are using the basic project management practices. You are using different estimation techniques, such as you are using size and cost estimation techniques, like function point analysis, COCOMO, etc. They are used. But the production process is still ad hoc. It is not formally defined and also not documented. You have not formally defined and not documented, or some project management practices you are using. If these things you are doing, that means you are in level 2 or repeatable stage. The process used for different projects might vary between the projects. So if you are using if you are developing different projects, the processes you are using might be different. The process used for different projects might vary between projects. The earlier succession projects with similar applications can be repeated. That's why the name is repeatable stage. What success you have got earlier for similar type of applications, you can repeat them here in order to get similar success. So earlier succession projects with similar applications can be repeated. That's why the name is repeatable stage. Opportunity to repeat process exists when a company produces a family of products. So when you are developing similar types of products, a similar family of products, then opportunity is there to repeat the processes. Okay, so opportunity to repeat process exists when a company or an organization produces a family of products. So what is the drawback I have already told you? In level 2 or repeatable stage, they are not formally defined, they are not documented. So next thing is, we must define the process, we must document the process. If you can do that thing, then you can go to level 3 or defined stage. So let's say level 3 are defined. So as its name suggests, defined, if your organization is evaluated at this stage, then the management and the development, that means the following conclusion you can draw. The management and the development activities, they are defined and documented. So now the activities and processes, management and development activities, they are defined and they are documented. So there is common organization-wide understanding of activities, roles and responsibilities. So across the organization, common organization-wide understanding of activities, roles and responsibilities are there. So these are activities. These activities are followed in level 3. If you are assessed that your company, your organization is at level 3, that means the following activities are carried out in your organization. Mainly, the management and development activities, they are defined and they are documented. The process Though defined, now let's see what is the drawback. Even if the process that you are following, though defined, but process and product qualities are not measured. You are not measuring the qualities. You are not measuring the process and the product qualities. Okay, even if you are defining the process, but the process qualities and product qualities are not measured. So if you can measure those things, then easily you can go to the next level, that is level 4. So last class we have discussed ISO 9000. If we will compare ISO and SCI CMM, then you can see that ISO 9000 aims at achieving this level. So if you will compare with ISO 9000, it aims at achieving this level. That means level 3. Then you'll go to the next one, that is level 4. Level 3 drawback I have already told you. Here the process and product qualities are not measured. So next we should try how we can measure the process and product qualities. If you can measure that thing, then we say that you are evaluated, your organization is evaluated as level 4, which is called as managed. So if your organization is assessed at level 4 or managed level, what conclusion you can draw? You can draw the following conclusions. Qualitative quality goals for products are set. Okay, for the products, some quantitative quality goals are set. This is the target, and if you can do quantity, if you can measure the process quality and the product qualities. So if you can measure the process quality and the product qualities, then you can set targets and you can try to achieve those targets. So if your organization is rated, is assessed as level 4, then you can conclude that in your organization, quantitative quality goals for products are set. The software process and product quality is measured in your organization. The software process and product qualities, they are measured. The measured values are used to control the product quality. Why you are measuring? See, if you cannot measure, then how you can improve? If you know that yes, this is the rate of rate of failure, this is the number of faults, this is the reliability. Only when you can measure, then you can try to improve. If you cannot measure, there is no way to improve it. You cannot improve. The software process and product qualities, they are measured. These measured values are used to control the product quality. The results of measurement used to evaluate project performance. So these results of measurement, they can be used to evaluate the performance of the project rather than improve the process. Please see, these values you are measuring, the measured values or the results of measurement, they can be used to evaluate the performance of the project, to evaluate the project performance of the process. So you are not trying to improve the processes using the measured values, rather you are trying to evaluate the project performance only. You are trying to evaluate the project performance only instead of or rather than improving the process. So now if you can improve the process, if you can continually improve the process based on these measured values, then you can say that you can go to the next level, that is level 5. So other conclusions that you can draw if you are rated at level 4 are as follows. The organization sets quantitative quality goals. I have already told you. If you are assessed at level 4, then it is assumed that your organization sets quantitative quality goals. Worldwide, about 100 organizations are set at this level. So if you see worldwide, 100 organizations approximately, they are assessed at this level. This is a little bit old data, might be under 10, 20 might have been added, that I'm not sure. You can check. So worldwide about 100 organizations are assessed at this level. Then we'll go to the next one, that is level 5. This is named as optimizing level. So if your organization is assessed at optimizing level or level 5, what conclusion you can draw? You can draw the following conclusions. Statistics collected from the process and product measurements are analyzed. In step 4, we have measured the different qualities, process and product qualities. We have measured them. Those measurement may be in terms of quantity, some statistics. Now, based on the statistics, how we should try to improve the process. That is the major idea behind achieving level 5. The statistics collected from process and product measurements, they are analyzed, then continuous process improvement based on the measurements. Okay, analyzed and continuous process improvement based on the measurements is done. You try to continuously improve your process based on what? Based on the measurements that you have already done. So measurements you have already done in level 4. If based on the measurements you can try to continuously improve the process, then you say that you are in, you will be assessed at level 5 or optimizing level. Some known types of defects are prevented from recurring by tuning the process. Okay, so if some known types, you know these are the defects, or you can anticipate these are the defects. Some known types of defects, they are prevented from recurring by tuning the process. If you tune the process, some known types of defects, they can be prevented, they can be avoided from recurring again and again. Lessons learned from specific projects incorporated into the process. So what lessons you are learning from the previous projects, those lessons you can incorporate into the current process. Lessons learned from the specific previous projects, they are incorporated into the process. So if you are assessed at level 5, these conclusions, these inferences can be drawn. So now what other things you have to do, or what in order to reach level 5, what other things you have to do? You have to identify the best software engineering practices and innovations. What are the best software engineering practices and innovations? You should follow them. Now, like the different automated tools, or different methods, or different processes, they can be used, they are identified, then they are transferred throughout the organization. Which are the best tools, best methods, or best processes you have to identify, and they can be transferred throughout the organization. So in order to level 5, you have to do these things. Worldwide, about right now, more than 500 organizations have been assessed at this level. That means at level 5. Okay. Then an important thing I want to say, that is called as KPA. This is known as key process area. So here each level is associated with a key process area. So we have seen 5 levels. Each level, starting from the level 1 to level 4, each level is associated with a key process area. And what does key process area does? This key process area identifies KPA identify the following. Where an organization at the previous level must focus to reach this level. That means in order to, so let's see, KPA 2 means what? That means where an organization at the previous level must focus to reach this level. So in order to reach at level 2, at level 1, what you have to do? Level. So let's see, for each level, what are the KPIs required? We'll start level 1, no KPI is required, because you are at the basic level. Now for level 2, what will the KPI? That means the activities that you must perform. What, again I am repeating, what is KPI? KPI means you have to identify where an organization at the previous level must focus to reach this level. In order to reach at level 2, at level 1, what you have to do? That is known as KPI 2. So we are doing level 2. Let's see what are the KPIs for level 2. Level 2 KPIs. And you have already seen in level 2 means what you have to do. You can see the figure. In level 2, you have to follow standard consistent processes, and explanation I have told. You have to use basic project management practices like tracking cost, schedule, and functionality. You have to use size and cost estimation techniques such as function point analysis, COCOMO, etc. So that means those things become what? The KPA for level 2. If at level 1, you can follow these things. You can use basic project management practices. You can use the size and cost estimation techniques. Then easily you can go to level 2. So these become the KPA for level 2. That's what I want to say here. So level 2 KPIs are the following. You have to perform software project planning. You have to do tracking of size, cost, and schedule. You have to monitor the project. You have to perform confusion management. You have to perform subcontract management. If all those things at level 1 you can do, then you can easily go to level 2. Similarly, what are level 3 KPIs? You know, level 3 stands for definition. That means if at level 2, if you can define the process, if you can document the processes, if you can carry out the reviews, we have seen the code reviews, etc. If you can carry training programs, easily you can go to level 3. So what are the level 3 KPIs? That means what activities you should carry out in level 2 to go to, so that you can go to reach at the next level. So level 3 KPIs are, you have to define the processes, you have to define the process and you document the processes. That means process definition and documentation, reviews and training program. If those activities you will perform at level 2, then you can easily go to level 3. That's why these are known as level 3 KPI. What is level 4 KPIs? Level 4 stands for measurement, so or managed. So if at level 3, if you can perform quantitative measurements, if you can measure the various qualities of these processes, then you can go for level 4. Also, if you can manage the different processes, if you can manage efficiently the processes, process management, if you can follow proper, if you can follow suitable process management strategies at level 3, then you can go to level 4. So level 4 KPIs are quantitative measurements and process management. Then level 5 KPI, we have already known. Level 5 stands for continuous improvement. So here, if at level 4, you can prevent the commonly occurring defects. If you can adopt technology change management, if you can adopt process change management, then you can go for next level, that is level 5. So in level 5, what you can do, if you can
Excuse me, sir.
defect prevent, yes.
Sir, we are still
Yes.
at level 1. We are still at level 1 slide.
Level 1. So already there. So now is it visible? Hello? Hello?
Yes, sir.
It is visible?
Sir,
KPA?
key process areas.
Yes. Okay. Then it is okay. I'm just, so key process area, I have already told you that the activities, what you have to do for an organization at the previous level, must focus to reach at this level. Those are called as KPA. Level 2 KPA, I have already told you. That means software project planning, size, cost, tracking the size, cost, and level schedule, project monitoring, etc. If you will perform confusion management, you have to perform subcontract management. These are the level 2 KPAs. Then level 3 KPAs I have told. Level 3 stands for definition. You have to perform process definition and documentation. You have to perform reviews. You have to carry out training programs. These become the level 3 KPIs. These things you must perform at level 2 so that you can go to level 3. Similar level 4 KPIs. You know, level 4 stands for managed. So if at level 3, if you can perform quantitative measurements of the quality attributes, if you can perform process management at level 3, then you can easily go to level 4. And level 5, you know, continuous improvement. So if you can perform defect prevention, if you can adopt the technology change management, and if you can adopt process change, if you can adopt the process change management at level 4, then you can easily go to level 5. So these things, defect prevention, technology change management, and process change management, these are the KPIs for level 5. Okay. So this is a repeatable model, how you can easily repeat. Like you see, the inputs are the input, the requirement You have to control the budget, schedule, standards, what resources you have to use, staff, tools, etc. Those things you have to take as inputs. Then you construct the system model, and the outputs will be what? The code and documentation. This is a repeatable model. Repeatable model means level 2. For level 2, the model will look like this. Input, you have to take the inputs. The inputs could be the requirements, various control strategies like tracking the budget, schedule, and standards, etc. Different resources. Based on that, you build the system model, construct the system model. Then what output you will get? The code or the documented code. So repeatable model KPIs, to move to repeatable model or level 2 model, please concentrate on. To move to this model, you have to concentrate on what? Confusion management, quality assurance, subcontract management. You have to make proper project planning. Already we have discussed project planning earlier. You have to also perform project tracking and oversight, and you have to what? Perform measurement analysis. So this is a repeatable model KPIs. So for repeatable model, these are the KPIs you must focus attention on these activities so that you can reach the repeatable model. This is a defined. Similarly, for defined process, this is a model, like you have to define here. Take the requirements, the design, different design methods, different tools, staff members, etc. Then what you do, as its name suggests, define model. You have to design and define the process. Then you can perform the system design. From system design, then you can go for coding and unit testing. And during coding and unit testing, you can use different inspection criteria, again tools, stuffs, etc. And after coding and unit testing, you will get the tested modules. Unit testing, perform integration and system testing. And when you are getting the system software, you can use the test plans, tools, stuff, etc. And by performing integration and system testing, you can get the system software. This is a defined process model for level 3 or for a defined process. This is the model. These are the repeatable. What to define, how you can move from repeatable stage to defined stage. These are the KPIs. You have to concentrate on the requirements development and technical solution. V&V activities, that means verification and validation activities. You have to perform integration of different products, product integration. You have to perform risk management. You have to arrange organizational training among the different stakeholders, organizational training, organizational process focus or functionality of the organization, decision analysis and resolution. You have to define the processes, because you want to go to defined stage. So you have to define the processes or process definition and integrated project management. Various project management activities you have seen, like what your staff management, time, schedule management, resource management. So you have to perform some integrated project management. These are the repeatable to defined KPIs. Similarly, this is a model for a managed process. I mean level 4. Take inputs are requirements, design methods, tool stuff, etc. Then design and define the process. Up to this, it is level 3. Then from this design and define of the processes, you perform this system design, and whatever these things already have shown in the previous model. These blue things. In managed process, what additionally we have to do? We have to manage several things. What we have to manage? One is the defects. You design the defects, manage the defects, directives. Then coding. If what are the in the coding stage, what are the coding errors? Try to manage them so that next time you will not get so many numbers of errors. Similarly, system errors during integration and system testing. What system errors you are getting? Try to manage them. So basically, here you are performing some measuring and management activity. This is a managed process. So in order to move from defined to managed stage, what are the KPIs? You have to concentrate on the organizational process performance, quantitative project management. Quantitatively, we have to measure. So we have to. So in order to move from defined to managed KPIs, also in order to move from defined stage to managed stage, or level 3 to level 4, the following KPIs are required. We have to concentrate on organizational process performance, as well as we have to measure quantitatively different quality attributes. Quantitative project management has to be performed. These are the KPIs for level 4. That means from moving defined stage to managed stage. Only one left, that is this optimizing. So these things already we have seen, level 3 and level 4. Maybe the old controller development system. These blue things are we have seen in the level 3 model or defined stage model. Then in 4 we are managing the errors, decoding the errors, we are managing the directives, we are managing the system errors, and if we want to optimize them, continuously will improve. That's why I see this is bidirectional. Continuously will improve, then we can reach at the optimized stage. So this is the model for the optimizing stage. Now, what are the KPIs for optimizing stage? I have already told you, just rewording them. In order to move from level 4 to level 5, that means for managing stage to optimizing stage, we have to concentrate on the causal analysis and resolution. We have to perform causal analysis and resolution, how the different errors can be avoided, how the what errors or the problems they can be prevented. We have to focus on that. Then we have to also focus on organizational innovation and deployment. How new things you can innovate. See, every time you see there are, you take the simple examples of cars, you take the traditional cars, how they were looking like, but nowadays you see cars, every time they are adding some new features, some innovative ideas. So we have to concentrate on the organizational innovation and deployment activities. Let's quickly look at the comparison between ISO 9001 and SPM. Last class I have already told you that ISO 9001 was awarded by an international standards body by different registrars located at different countries. This ISO 9001 certificate can be quoted in official documents and communications, but SPM assessment is purely for internal use, not to showing the outside world. So this is purely for internal use. SPM was developed specifically for software industry. So hence it addresses many issues which are very much specific to software industry, because this model was SPM was developed only for software industry. SCI goes beyond quality assurance. It aims for TQM. If we will see, yesterday we have seen about these different evolutions, such as this quality control, quality assurance, then TQM. So SCI goes beyond quality assurance. So after quality assurance, which evolution? TQM. It aims for TQM. And if you will compare ISO 9000 SCI CMM, I have already told you ISO 9000, it corresponds to which level of SCI? It corresponds to, it targets, it aims at achieving SCI level 3. Okay. SCI CMM model, it provides a list of key process areas on which to focus to take an organization from one level to another. So if you see SCI CMM model, it provides some KPIs, key process areas by following which, by focusing on which. So these areas will take an organization from one lower level to another higher level. It provides a way for gradual quality improvements over several stages. You can gradually, directly, it's not better or it's not good that you should try to jump from level 2 to level 4. You should first try to go from level 2 to level 3, then level 3 to level 4, then level 4 to level 5. It provides a way for gradual quality improvements over the several stages. Trying to implement a defined process before a repeatable process may be counterproductive as managers are overwhelmed by schedule and budget pressure. Don't try to jump from directly initial to defined. Try to go from initial to repeatable, then from repeatable to defined, then defined to managed, and then managed to optimized stage. Don't jump from one step to another step. So nowadays, another advanced version of CMM has come, that is known as CMMI, which stands for CMM integration. The CMMI is the successor of the CMM. The CMM model was developed from 1987 until 1997. In 2002, CMMI version 1.1 was released. Version 1.2 followed in 6. Now, let's know what is the goal, what is the objective of CMMI. The goal of CMMI is to integrate many different models into one framework. There are different models, so you can The objective of CMMI is to integrate many different models into one framework, into a single framework. It was created by members of industry, government, and SCI. So this CMMI model, it was developed, it was created by the members from industry, government, and SCI. Okay. Some suggestions about CMMI. CMMI is suitable for large organizations. For example, need for special quality assurance and process improvement groups for larger organizations who need for special quality assurance and process improvement. Then CMMI might be suitable for those organizations. Defining processes may not be easy with new technology. How can we plan when we have not used the development method before? So if a new technology we have not used, then how we can using the development method? For example, now we are developing a project using 5G. Okay, 6G it has not come to the market. So how we can think of that? How we can plan, keeping in mind that 6G technology will come maybe next year? Very much difficult. So defining processes may not be easy with new technology. For example, how we can plan when we have not used the development method before? Higher CMM levels easier with maintenance environment. So if you are going to higher levels of CMM like measurement or optimized, that means level 4 or level 5. So their maintenance environment is quite good, easy for maintenance. So higher CMM levels are easier with maintenance environment. So here maintenance environment is there, higher CMM levels will be easier to implement. Can you jump the levels like HP level 5 in India? So can you jump the levels? Actually, advice is not, you should not jump from directly level 1 to level 3. You should go from level 1 to level 2, then level 2 to level 3, then level 3 to level 4, and then level 4 to level 5. That's the advice. You can know that HP level 5 in India. In India, that HP company, it is assessed at level 5. Okay. So these are some of the suggestions about CMMI. Don't try to jump from a lower level to directly to a much higher level like 1 to 3 or 2 to 4. This kind of should not be what recommended. Okay. So some remarks on quality model usage. These are highly systematic and measured approach to software development process which suits certain circumstances. Now we're discussing some remarks on the quality model usage. Highly systematic and measured approach to software development process which suits certain circumstances. So these models we have seen like SCI-CMM. These are highly systematic and measured approaches to software development process which suits certain circumstances. For example, negotiated software, safety critical software, etc. For them, these SCI-CMM models, they will be very much appropriate. But what about small organizations? If your organization is very small, just to typically handle applications, okay, just you are using some internet applications, e-commerce applications, what you will do? Whether CMM will be appropriate? What about small organizations? Those but typically handle applications such as internet, e-commerce, or etc. without an established product range, without revenue-based experience on, they don't have experience on past project, etc. So should we go for CMM model? Whether CMM model is suitable? The answer is not. It is no. The answer is no. CMM model may not be suitable for this type of small organizations. CMM model may be incompatible for these small organizations. Okay. Today we have discussed the basic concept of SCI-CMM. We have seen that there are 5 levels starting from initial level, repeatable level, then defined level, then managed level, and then optimized level. We have compared the differences. We have compared between the standards ISO and SCI-CMM. So these main things we have seen. We have also seen a variant of CMM, that is CMMI, where I stands for integration. So we have seen some of the remarks on CMM and CMMI. This is all about CMMI. You can read yourself. So we have compared between ISO and SAICMM. Okay. These things we have taken from this software project management book and this software engineering book. So, and one thing only, due to lack of time, I am not covering that PSP, Personal Software Process, and Six Sigma. We are running out of time, but the slide I will put, you can read yourself. May not come in the examination because I have not covered in the class. But if you want to know, because nowadays everybody is talking about Six Sigma. So what is Six Sigma? At least you should know. So those things I will put in the Microsoft Teams. That slide I will put. You please read yourself. Okay. Thank you very much for your presence, hearing. Now let's take up any questions, please. Yes, any questions? Little bit easy. You should try to understand.